This summatory is very easy. We just need to write the terms back to forth and then divide by 2. Now we want to add only odd numbers. And as we draw squares with one unit added each time to the side of the square, we get the conclusion that 1 plus 3 equal to 2 raised to 2. 1 plus 3 plus 5 equals to 3 raised to 2. If we have any, we can reach that as is equal to n raised to 2. Now we want to calculate 1 raised to 2 plus 2 raised to 2 and n raised to 2. And we draw cubes and we will calculate the number of squares on each face of the cubes with side 1, 2, 3 till n. The first cube has 6 faces. The second, with side equal to, has 6 times 4 squares on each face, 24. The third, with n equal to 3, we have 9 squares on each face, and with the cube 6 face, 6 times 9 is equal to 54. So if we continue in summing, adding these numbers, we can find that the sequence of numbers is 6, 30, 84, 8 on the number of the face of the cubes. For n equal to 30 squares, then 84 squares. If we continue this process, we get the conclusion that the number of squares per face on each cube is equal to 6 times the sum that we already know, that we want to know. 1 raised to 2 plus 2 raised to 2 plus 3 raised to 2, etc. So we know that the series 6, 30, 84, 108 is 1, in the case of 6, 1 times 2 times 1 plus 2. For n equal to 30 is equal to 2 times 3 times 2 plus 3, and etc. So what we want to calculate is the sum of 1 raised to 2 plus 2 raised to 2 until n raised to 2. And the number of faces is equal to n times n plus 1 times n times 2 plus 1. So the only thing we have to do is divide this number by 6. Now the series 1 raised to 3, 2 raised to 3 until n raised to 3. Let's draw cubes. Now we calculate the volume of each cube and then add them up. The first cube there has only 1. The second, 2 raised to 3 is 8. The third is 3 raised to 3, 27, and so on. If we sum the volumes of each cube, we can get to 1, 9, 36, and 100. 225. Well, looking at these numbers, we see that 1 is 1. 9 is 1 plus 2 raised to 2. 36 is 1 plus 2 plus 3 raised to 2, and so on. So we guess it's not a mathematical formal proof that the sum we want is 1 plus 2 plus k raised to 2. That we already know. That's k times k plus 1 divided by 2. So the sum that we want is n times n more 1 divided by 2 raised to the power of 2. Essa é a solução formal para calcular qualquer soma. Fórmula de Faulhaber, que precisa dos números de Bernoulli e que tem na internet.